In this lesson, we're going to take a look at solving using the zero product property. A factored equation with an equal zero is what we've been working to be through all of our factoring techniques. We've been working to get here so that we can do the solving to figure out where these graphs touch the x-axis. So the whole thing goes down to the zero product property. The zero product property says that any products, when set equal to zero, require that either A is zero, or B is zero, or C is zero. And so what we do is identify where these things are broken up with multiplication. Because if A is zero, the whole statement is zero. If B is zero, the whole statement would be zero. If C is zero, because we know that multiplication of zero causes it to be zero. So our job is to take each one of these products and separately figure out what would cause this piece, the A piece, the B piece, the C piece, to be equal to zero. So to do that, we separate at products. So you got to identify that the parentheses are being next to each other. The products of variables and the next term will cause, or the next factor, I meant to say, what would cause it to be zero. So we set each one 2x equal to zero, and we solve that statement. We set x plus 3 equal to zero, and we solve that statement. And then finally, we set 4x squared minus 25 equal to zero, and we solve that statement. There's basically three equations to solve because there were three factors written together. As many factors you have will cause as many equations to solve. And you can do them as quick as they work for you. If you can see the number that you would plug in that would cause this to be true, you found it. If you need to do the algebra inverse operations, great. We just got to figure it out one way or another. So I'm going to divide by 2 to do the inverse operation to see that x equals 0 over 2. Well, one answer then is 0. Because 0 would cause this whole thing. If I put a 0 right there for x, the whole statement would be 0 and true. And then right here, I could see, I'm just looking at it, I know negative 3 plus 3 would be 0. And so that's the answer. But here the inverse operation would be subtract 3 from both sides, and you get x equals negative 3. So my second answer is negative 3. This quadratic expression, it's quadratic because the degree is 2, has two answers because there are two things that will work and cause this to be true. So I'm going to use inverse operations and solve by square root method to work this one up top. So the first thing you would do to solve this one is add 25 to both sides. And then we get 4x squared equals 25. Divide both sides by 4. And you get x squared equals 25 over 4. And to finish, you solve by this. I was solving by the square root method, so I square root both sides. And when I solve by the square root method, I have to remember there are two answers that will work because I can square a negative in there. So I have to have a positive and a negative solution. And the square root of 25 and the square root of 4 can be done independently when you have a square root. So this is plus or minus 5 over 4. 2, I meant to say. Because the square root of 25 is 5. The square root of 4 is 2. So it's plus or minus 5 halves. And so we have 0, negative 3, and then plus or minus 5 halves. That's 4 solutions to this factored form polynomial. Now I picked this problem. It's actually easier than the last one, but many students that consistently over the years tell me 3 is an answer. 3 is not an answer. 3 is a constant, a coefficient out in front that actually amplifies the graph. It does not cause an x-intercept. It needs an x next to it to make a 0 occur, and it would have been x equals 0 is usually the front term. This 3 does nothing for intercepts. You could distribute it in a parenthesis, but it does not cause an x-intercept. The products that we look at are the ones with x's that get set equal to 0. So this problem is only about setting x plus 8 equal to 0 and x squared minus 81 equal to 0. And then we get 3 answers. By the way, however many degree you have, there's 2 and 1 is how many solutions you're going to get. Sometimes we'll get imaginary solutions later. So in this case, we subtract 8 from both sides, and we get x equals negative 8. That's one of our answers. And then this x squared minus 81, maybe you're just really quick and see it's plus and minus 9, because 9 squared is 81, and 81 minus 81 is 0. Positive 9, or negative 9 will work. But here's the algebra using the square root method, if you like. So I add both sides by 81. And that's going to give me x squared equals 81. And then the square root method, we must not forget when we square root, we have to get a plus and a minus. So the x squared square root is x. And then the plus or minus 81 is square root of 81 is plus or minus 9, because the square root of 81 is 9, and then we leave the plus or minus. So we get two answers from that one, and then our additional negative 8. So negative 8 and then plus or minus 9 are the 3 answers I needed. Please don't add the 3. 3 is not a solution. 3 is just an amplifier, a vertical stretch. All right, in this zero product property setup, we've got something that's not fully factored. It's more convenient when it is fully factored. It says factored form, but it's not fully factored. And then we've got x squared plus 16. So this part, I could factor it, use difference of squares to factor it. I'll just use the square root method, because that's going to lead me well here in the x squared plus 16. So both of these first, x squared minus 49, set that equal to 0, and then x squared plus 16 equal to 0. So what we want to do is set that equal, or set x, isolate x using the square root method, and x squared minus 49, I'll add the 49 to the other side, and hopefully you're seeing it 7 already, but x squared equals 49, and then you solve by the square root method, and you get your plus or minus square root, and that gives me x equals plus or minus 7. That's great, but this one is going to give us some issues. So we've got x squared plus 16 equals 0. Anytime you have an x squared plus, just expect there will be imaginary solutions following. So we've got x squared. We got to subtract 16 from both sides. X squared equals negative 16. And that's impossible to have a square equal a negative. And of course, we've learned our way through that is when we square root with the plus or minus, we can say x equals plus or minus I square root of 16, because we know the square root of a negative 1 is I. So really, the square root of 16 still plays, and that's 4. So x is equal to plus or minus 4i. Now notice how I wrote that. When I pull out the I put it in front of the square root, and when I do the square root and evaluate it, I put the number in front of the I. That is our standard form for complex numbers. So we've got plus or minus 7, and then plus or minus 4i is all the solutions for this factored form for x. And notice I have 4 solutions, 2 real ones, 7 and negative 7, and 2 imaginary ones out of this one, the plus or minus 4i. Total of 4 complex solutions, including the real and the imaginary.